All right, algebra students, so the last video that you watched, we've been working on graphing inequalities. So remember, we're dealing with problems that have greater than or less than, or greater than or equal to, or less than or equal to. And so you've been using Desmos to do a couple of things. You've been using Desmos to graph the inequality, which is going to have an x and a y in it. It graphs it on the coordinate plane since we have x and y values. And you're also given a shaded area, which is, in this case, it's the quantity 4 times x plus y is greater than -4. And so when it graphs it on the greater than side. And so you're given an area of solutions. And then you're also given whether it's a solid or dotted line. So remember that if it's a greater than or less than symbol, you're going to have this dashed line, which means that this line is actually not included. It's just everything greater than it. If you were to have, of course, a line underneath there, which would be the equal to sign, remember this line would become solid. Can't draw a straight line to save my life, but that line would become solid, and those points would be included in the solution. And so if you notice, and again, this is just a review of where we've been. If you'll notice, I've graphed a couple of points, 4, 5, so just kind of answer to yourself, would 4, 5 be a solution? And in this case, yes, it is because it's in the shaded area. -4, 12, which is this green dot right here, would that be a solution? Well, no, not in this case, because of course the original graph was just greater than, and any point that is on a dashed line or dotted line is not included because we're including everything greater than, and this is actually on the line. Now, if this had the solid line, then of course it would have been included, but in our case it was not. So the green line is not a solution, so this was a yes. Oh, terrible check mark. This is a yes, this is a no, and then -2, 7 would be a solution. Anything over here in the white area, remember, is not a solution. So something like -5, 1 would not be a solution. And so that's where we have been. And so today we're going to move into what we would call systems of inequality. So I just want to review a little bit of where we've been. At the beginning of the year, and this is just sort of my way of sort of organizing how you should have these things in your brain. So you have learned what an equation is and how to graph an equation. And that was back in the second unit that we did where we started graphing lines, and you learned about slope and you learned about y-intercepts. So we've learned how to graph equations. And then also a couple of units ago, we learned how to, actually last unit before inequalities, we learned how to graph systems of equations, which was those 2 lines, remember? And that was when you learned substitution and you learned elimination. But we also, at the end of the day, learned that if you have 2 equations, which just create 2 lines, and if you graph them in Desmos, then you can find the solution by finding the intersection point, right? So that was last unit, the very end of last unit. So an equation, of course, is a straight line. System of equations is 2 straight lines. What you just learned last video is an inequality, which is a straight line, graphing a line, but you also get the shaded region, right? Because we're now talking about greater than or less than. So inequalities are related to equations in that they are lines, but they have this shaded because of the greater than or less than involved in it. And so what we're getting ready to learn today would be what we call system of inequalities, which is related to a system of equations in that we're going to have 2 lines. However, because they're inequalities, we are now going to have 2 shaded regions, which gets a little tricky. If you'll notice in this picture, I've chosen red and blue because when you mix red and blue, it gets purple. So we have sort of almost 4 regions that are created here. Again, remember, a solution for a system of equation is just where they cross. Well, when we get a system of inequalities, what we have is a region that crosses. Not just a single point, but now a region that crosses. So if you'll notice, in this system of inequalities, there's this red line. And whatever this line is, its y-intercept is 4, and it looks like it has a slope of up 1 over 2. So actually, I would say that this line right here probably is y is less than or equal to, because it's a solid line. The slope is 1/2, so it's probably -1/2, it's going downhill, -1/2 x plus 4. So that would be the graph of the, and I'm just using y-intercept there, and then the calculation of the slope, down 1 over 2 to get that equation. And then if you'll notice the blue line here is dashed, I'll write it in blue, it has a y-intercept of -3. So this is probably y is, and notice the blue is getting shaded below, so it's probably y is less than. It's dashed, so it's just less than. And the slope here looks like 3 over 1. So that would be 3x and then -3 because the intercept is 3. Now, you don't necessarily have to, although we have done slope and we have done intercept, so you should be able to pick that out. You don't necessarily have to do that in this unit. All I want you to realize here is that we do have two inequalities that are being graphed. This inequality that's in red and this inequality that's in blue. But notice, and I'm going to take the graph, I'm going to take the equations away for just a second so we can actually see them. So once we get those graphed, again, what we have is we have everything that is less than the red line being shaded. We have everything that is less than the blue line that's being shaded. And so where these graphs intersect in the region that they shade is now going to be my solution area. Now, just like when we did inequalities, solutions also include solid lines. So if we had a point right here on this line, it would be a solution. However, if we have a point on any kind of dotted line, it is definitely not a solution. And so let's graph a couple of these and let's see what they look like in Desmos and what they actually look like. So we are working on systems of inequalities, two inequalities with two shaded regions that are going to overlap. So let's look at what one might look like. So here is an example. It says to graph y is less than 2x plus 3 and y is greater than or equal to -3x plus 2. So let's flip over to Desmos. Go ahead and maybe have that open on your computer as well. And we're going to type in y is less than 2x plus 3. And we're also going to type in the second one, which is y is greater than or equal to. You can get that from the menu down here. Or remember, you can type in greater than, the greater than symbol and the equal to sign at the same time, and it'll also graph it. -3x plus 2. All right, so again, notice. And I think the default colors on Desmos is red and blue. Remember, you can always click and hold and you can change the colors. I like keeping it red and blue because it kind of, red and blue mix to make purple, and it makes it a little more clear to see where the overlap is. Also, remember, you can click on these colors and it will turn the graph off. So sometimes that's also helpful to sort of see what is the overlap. So here we have, let's look at the red graph first. Here we have the red graph, which is everything less than this line, which is dotted. So nothing on this line here is included. But now we're looking for the overlap between this blue line, which is solid, and everything is graphed above it. So notice that we have this blue region, this red region, but the region of our solution set is going to be what is overlapped or in the purple. Now, nothing along this dotted line is going to be included because, remember, we're looking for everything less than it. But on this solid line here, it is going to be included. Now, part of something that does not get included is this solid line up here because so it has to be in the overlapped region, has to be in the purple, and along a solid line, or anything in the purple, of course. So let's check a couple of points. If we go back to our screen here, it asks us to check a few points. So 0, -6. Let's see if 0, -6 is going to be a solution. Is 0, -6 a solution? Oh, there it is. It's down here. So is 0, -6 a solution? Well, it is in a shaded area, but remember, our solution area is the double shaded, is what is included in both regions. And although this is in the red, it is less than this line. It is not above this blue line, which is also shaded. So we would say that no, this is not a solution because it is not in the double shaded area. All right, what about 0, 8? So let's go type it in. 0, 8. Of course, if I could type, it would help. 0, 8 is up here. Is 0, 8 a solution? Well, again, it's in the blue. It is above this blue solid line in the shaded region, but it is not below the red region, which it has to be at the same time. So again, we're looking for something over here in the purple. So 0, 8 is also not, oops, I'm on the wrong screen. There we go. 0, 8 is also not a solution. All right, and then the last one we're going to check is 6, 0. Is 6, 0 a solution? So 6, 0. Now we finally find one that actually is in the purple region. It is in the double shaded region. and it is a solution. Now, one we didn't check, and one that a couple that I want to make sure that we talk about is, what about if we had 1 negative 2? 1 negative, nope, not that one either. 1 negative 1, I'm sorry, my scale is off. All right, let's look at this point for just a second. Is 1 negative 1 a solution? So although it looks like it's not maybe like over in the purple region, it is included because it's on the solid line and it borders the purple region. So remember, we're looking for everything that is on or above the blue line or below the red line, and this does fit that. So negative 1 would be a solution because it's on a solid line in the double shaded region. However, something like, let's see if I can find one. Something like 1, 5 would not be a solution. So even though it does border the purple, it is in the double shaded, it is on a dotted line, and so that would not be included in the solution. So what we're working on here is very similar. So actually this was a yes, right? When we were talking about 6, 0, that was this point over here. It was in the double shaded region. So really, it's very similar to what you have been working on with one inequality, only now we're looking for solutions that are, again, in that double shaded area. So let's look at our second example. And again, have Desmos out and open. Let's see if maybe you want to pause the video here and see if you can answer these questions, yes or no, and then we'll check them. All right, so I hope you've taken time to pause the video and maybe do this yourself. Let's type in these equations. So x plus y is greater than negative 2. And then we also have negative 3x plus y is less than or equal to 6. And so we get another set of inequalities that overlap. Notice my colors here are green and purple. Again, you can change them if you want to. I'm actually going to change them to, what if we change them to blue and yellow? We'll make green. Yeah, let's try that. All right, so there, oh, it's kind of orange, but that's okay. We can still tell what is double shaded, which is the intersection between the two. Anyway, all right, so there's what our graph looks like. So now we're going to go back and we're going to look at the points that we're checking. So is 8, negative 5 a solution? So we're going to check that one. 8, negative 5. Is that in the double shaded area? And it is. It's in the orange and the blue at the same time. So that would be a yes for the first question. All right, let's look at negative 3, negative 3. So negative 3, negative 3. See where that lands. All right, so this one is on a solid line, which is a good thing. Which normally we would include things on the solid lines. Although notice, this is nowhere near any of the blue shading, right? If we were to have a solution on a solid line, it would have to be up here. It would have to be along this part. Once we cross over this dotted line here, these are only shaded orange, right? We don't have any blue anywhere near it. So up here would be solutions, but this is actually not a solution because although it is in one of the shaded areas, it is not in both. So this one would be a no. And then is 2, negative 3 a solution? So 2, negative 3. And that one would be because, again, it's in the double shaded region. So that would be a yes. All right. Let's look at a couple more. I want to look at a couple that have straight lines. So some of these may seem a little more straightforward. Notice in both of these, we only have an x and a y. So let's see what this is going to look like when we graph it. So for the next example, all we're going to do is type in, it was x is less than negative 2, which again, notice anytime you have an x or a y, it's just going to be a straight line. So this one was less than, and it graphs it at x equal 2 across the x-axis, and then y is greater than or equal to 5, which is going to be a horizontal line. And notice it's shading everything on or above it, so it's a solid line. And so we want to look at a couple of points. 6, negative 1, negative 2, 5, and 6, 5, and see if these are solutions. And notice again, because we have straight lines, we almost have quadrants here, right? So we have a purple, which is just shaded purple, just shaded green. Here, nothing shaded, but our solution area is going to be up here. So the point that we were first checking, I've already forgot it, is negative 6, 1. All right, so is that a solution? It's not, because it's not in the double shaded. It is in green, but it is not anywhere near the purple. So it has to be in the double shaded. So that would be a no. Then we're looking at -2, 5. So -2, 5. Oh, this is a great one. Is that a solution? So we have to think a second about it, because is it in the double shaded? Well, it's close, right? It's at least on the border. And so you should, when you get on the border of the double shaded, you have to ask yourself, okay, if I'm on the border of the double shaded, am I on a solid line or a dotted line? And that's going to really determine whether your solution is part of it or not. So am I on a solid line? Well, yeah, I have to be on or above the purple in order to be included, right? Remember, the purple is everything equal to or greater than y equals 5. So that's true. But to be included in the green, I have to be less than -2. And this is not less than -2. It's on -2. So it is near the double shaded. It's on the border. That was a check for it. It is on a solid line. That's a check for it. But anytime it is on a dotted line, you can always assume that it is not part of the solution. So this is actually a no, because it's not actually less than -2. That was a really good one. So this would be a no. And then 6, 5, let's check it. So 6, 5, is that a solution? I may have to go back. I'm going to click the home button so I can see what I'm graphing. So is that a solution? It is on a solid line, but it does not border the double shaded. So it is in the purple, but it is not less than the green dotted line. So that would be a no as well. All of those were no. All right, so I'm going to do one more. I'm going to let you type it in yourself and answer these 2 questions. So maybe pause the video one more time and make sure you type this in. Make sure you can do it, and then we'll check it, and then you're ready to practice. All right, so I hope you took the time to type this in. It probably looks a little weird. Both of them are y's, so let's see what these look like when we graph them. So it's y is less than 7 is our first one. So y is less than 7. And then we had y is greater than or equal to -1. Both of these are green. That's not good. If they come out to be the same color, let's change at least one of them. So let's make it blue and red again. Blue and red is probably my favorite combination, just because it does make the purple region. All right, now, if you zoom out a little bit, it's kind of weird looking. We get this, we've got like a blue region and a red region down here, and then a purple region in the middle. And if you click on and off of these, you can really tell what's happening here. So the red is a dotted line, everything below, but the blue is below it, and it's a solid line, but it's everything above. So when they overlap, we do get this sort of middle region that it's everything less than this dotted line and everything above this solid line. And so when we check our points here, 4, 4, a solution. So let's look and see where 4, 4 is. We're still just looking, is it in the double shaded? And 4, 4 would be a yes. It is in the purple double shaded. And then what about 2, 10? So we look at 2, 10. And it is not, because it is only in the blue. Same thing would happen if you had one down here in the red. That would not be a solution. Can you think of a point on a line here? If we had a point on anywhere on this dashed line, would it be a solution? It would not. Remember, anywhere on a dashed line is not a solution. But what about anywhere on this line? If we had the point, and I think that's at 1. So even if, let's see if we had the point, I don't know, 4, -1. Would that be a solution? That absolutely would, because not only is it in the double shaded, or it's on the border of the double shaded, but it's on a solid line. And remember, solid lines are included as long as they are on the double shaded. So that is systems of inequalities. And so again, remember, we have now sort of worked through all of these families. We've got equations, systems of equations, inequalities, and now we're working on systems of inequalities where your solutions are in the double shaded region or on a solid line on the border. And so you're ready to practice. Make sure you email me if you have any questions.